Hey guys, I'm going to go ahead and go through the practice exam. So if you missed something in class, you didn't have notes on it, or I went through it too quickly, hopefully you'll be able to pause this video and take your time and really absorb it. Like I said in class, the questions are going to be very similar to the ones on the final. And yeah, good luck. All right, I have a calculator here that someone graciously left me in class. So I'm going to use it, but I'll bring it to class on Thursday. Okay, so we're going to work through it. Okay, let's see. Exam 1 practice. Okay, here we go. So we work through these in class. The domain, of course, domain is going to be all allowable or possible x values. This t here, right? T values. So we can't have, looking at this function, can't have t minus 2 equal to 0 on the bottom. And we also can't have the inside of a square root less than 0. So we can't have t squared plus 5t minus 6. We can't have that less than 0. So part 1, t minus 2 not equal to 0. We're going to have t is not equal to 2. Add 2 to both sides. Okay, and for this part, t squared plus 5t minus 6. We're going to actually require that this is greater than or equal to 0. Right? We can't have that. Can't have it less than 0, so we want it where it's greater than or equal to 0. Right? So we're going to factor this. This is t plus 6 times t minus 1 greater than or equal to 0. Right? So we know that our roots of this function are going to be at minus 6 and positive 1. Right? Because it's a positive coefficient on the squared, this is going to be an upward facing parabola. So for x values or t values greater than 1 and less than or equal to 6, this function is going to be positive. Right, and that's what we want, right? So we can also see that we need them both. This is true when both of the factors are positive, or if both of them are negative. So both of them are positive. This is saying t plus 6 is greater than or equal to 0, and t minus 1 is greater than or equal to 0, which is the same as t is greater than or equal to minus 6, and t is greater than or equal to 1. Of course, together, this is t is greater than or equal to 1, right? Satisfies both of these. And for them both to be negative, we have t plus 6 less than or equal to 0, and t minus 1 less than or equal to 0. So t is less than or equal to minus 6, and t is less than or equal to positive 1, right? And so this is t less than or equal to 6. So altogether, we have all values of t for t greater than or equal to 1, t less than or equal to 6, except t equal to 2. Right? If we want to write this in interval notation, it does say interval notation. I probably won't ask that on the test, but this is going to be the same as in interval notation. This is going to be, we have all t less than minus 6, right? It's less than minus 6. So this is going to be minus, so we're going to go from, right, all t less than minus 6, we're going to come up from minus infinity, right? We're going to include the endpoint 6, right? And then we're going to want this union. We're going to start at 1, we're going to include the point 1, we're going to go up to 2, not include it, and then we're going to union 2 out to infinity, right? We don't have the point 2, but we're going out to infinity. So this is interval notation. Okay. Problem 2, solve the following equations. Of course, like we talked about in class, there's a handful of different ways to solve this one. We could set the bases equal method. We have 5x squared plus x equals 5 to the 0. which from our rule, x squared plus x equals 0, right? So x times x plus 1 equals 0, and so x equals 0 or minus 1, right? We could also take the logarithm method, right? We can take the logs of both sides, and the base isn't going to matter. I'm going to use the natural log, so we have ln of 5 to the x squared plus x equals ln of 1. Exponent on something that gives you 1 is 0, right? And so we're able to, by the power, the base exponent property of the log, we're able to say this is, pull this down outside of the log, right? We can divide both sides by ln of 5, so we have x squared plus x equals 0, divide both sides by ln of 5, and like before, we have this x plus 1 equals 0, so x equals 0 or minus 1, right? This is our answer. We're solving for x. Okay, in the logarithm here, we can do this a bunch of different ways. I think first it's easiest to combine this, so we're going to have log, and if it's not specified, of course, this is base 10. So log base 10 of the x plus 5. We're going to, because addition across the logs is the same as multiplying, this is x plus 5 times x plus 2. That's the logarithm of that whole thing, equals 1. Right? We can go ahead and write that out, FOIL that out. So this is going to be log of x squared plus 7x plus 10 equals 1. Right? We can go a couple different ways from here. We can raise both sides to the 10th power. Right? So 10 to the log base 10 of x squared plus 7x plus 10 equals 10 to the 1. All right, so this is of course raised to 10th power. And why was this useful? Okay, the reason we did this, of course, is because now this is going to go away. We can bring this down. So we have x squared plus 7x plus 10. And I'll say that the reason here is, 10, 2, and the log is the exponent on 10 that gives you this. So the exponent on 10 that gives you this. If you put that exponent on 10, of course, you get that. That equals 10, right? So x squared plus 7x equals 0, and x plus 7 equals 0, x equals 0, or minus 7. Right, I'll say, okay, now we have these two values. Does 0 work? Yes, we have log of 5 plus log of 2 equals 1. And minus 7, well, we can't plug in minus 7, so it's just x equals 0. We can't plug in minus 7 because we can't take the logarithm of a negative number, right? From here, the other way to get here was you could say, okay, based on the definition of logarithm is, the exponent on 10 that gives you 1 is this, right? So the exponent on 10 that gives you 1 is this. So the exponent on 10 that gives you 1 is x squared plus 7x plus 10. Of course, you're already down to this step, right? Right, so you could go there. This is from the definition of logarithm. Okay, x equals 0. Okay, limits, use the rules of limits. Here, okay, can't plug in minus 2 because we get a 0 on the bottom. So we're going to factor. So this is going to be equal to the limit as x goes to minus 2. We're going to factor out an x plus 2. Well, we're going to try, right? So we can cancel the bottom. And if we factor out an x plus 2, we're going to need an x minus 5. Right? Cancel, right? So this is going to be limit as x goes to minus 2 of x minus 5. Of course, this is a polynomial, so we can plug in minus 7. All right, the limit here as x goes to 1, well, as it turns out, we can just plug in. So this is going to be equal to 8 plus 1 square root over 1 plus 1, right, which is 3/2. We could be a little more laborious, right? This is also equal to, we could say this is equal to, we could pull the limit inside. This is going to be the limit as x goes to 1 of 8 plus x, right, over limit as x goes to 1 of x plus 1, right? Now we have polynomials, so we can strictly 8 plus x. We have polynomials, so we can use rule 5 of logarithms, right? So this is going to be, of course, square root of this limit is going to be square root of 9. Over here is going to be 2, right? Which is 3/2. Right? So you can be a little more precise about it if you want. Okay, so here we have a limit as x goes to infinity. So step 1, highest power in the denominator is x squared, right? 2, we're going to divide by x squared. X squared using, and then we're going to use the limit as x goes to infinity of 1 over x to the n equals 0, right? So if we divide by x squared, we're going to have this equals limit as x goes to infinity. We're not changing the equation by dividing by x squared on both sides of 8 minus 4x cubed times 1 over x squared, and this is going to be 5x squared plus 7x plus 10 over 1 times 1 over x squared, which is going to equal the limit. We're going to send this through. It's going to be 8 over x squared minus 4x, right? And this is going to be over 5 plus 7 over x plus 10 over x squared, right? Now we have this rule, right? So we can say 1 over x to the n is going to equal to 0. So here n is 2, here n is 1, here n is 2. So we can go ahead and cancel these to 0, right? And so those go to 0 by our definition there. So x goes to infinity of minus 4x over 3, right? And we say this is minus 4/3 limit as x goes to infinity of x, right? Which is going to be, of course, minus infinity, right? This function here, right? Of course, it's a negative exponent on, or a negative leading coefficient on this linear equation, right? So it's going to be a negative slope on this linear equation. And as x goes off to infinity here, y, the value of this function, is going to go off to minus infinity, right? Of course, this is just infinity because this is just a positive one. We pulled out the coefficient, and minus something times infinity is going to be our minus infinity. Similarly for this one, 1 highest power is x squared, right, on the bottom. 2, we divide. So this is going to be equal to the limit as x goes to infinity. I'm just going to go ahead and send this one right through. So this is going to be 5 over x plus 3 over 6 over x squared plus 7 over x plus 4. Right, we're able to cancel these 3. So this is going to be the limit as x goes to infinity of 3/4. There's no x here, so as x changes, this doesn't change. So this is just 3/4, right? Doesn't really matter what x does. If we were to think about what the equation this looks like, it's 3/4, right? As x goes to infinity, this function just stays at 3/4. Okay. This is using interval notation, give the interval if a function is continuous. Okay, well, we know ln is continuous for all insides greater than 0. So we need inside of the log greater than 0. Can't take the log of 0. And this is the ln, natural log base e. So here we have, on the bottom we have x squared. X squared minus 4 is continuous everywhere. And so, of course, their ratio is continuous where the bottom isn't 0, right? And the top. So we have two things. So it's continuous where x squared minus 4 is not equal to 0. And it's also continuous where 5 minus x is greater than 0. So here we have x, we can factor this, x minus 2, x plus 2 is not equal to 0, so x cannot equal minus 2 or 2, right? And here, this, if we saw that minus x is greater than minus 5, we subtract 5, multiply by minus 1, so x has to be less than 5, right? An interval, so both of these, x is continuous for all x less than 5, right, for the top, and also x can't be minus 2 or plus 2. So in interval notation, this is going to be, we're going to go from minus infinity up to minus 2, right? We can't have the value minus 2, right? We're going to go from minus 2 up to 2, right? We can't have the value 2, and then we're going to go up to 5. And we can't have the value 5, actually. So it's an open interval. We're not going to include that point. Okay, find the value k that makes this function continuous. This function is going to be continuous wherever wherever these two are continuous and possibly discontinuous at where they meet. So kx squared plus 1 is always continuous for any k. So is x plus k, right? But where they meet, this might be discontinuous. So to be continuous, we needed 1, that the function is defined, well, for any value k at f of x equals 2. F of 2 is going to be in here, because x is less than or equal to 2. We're going to be in here. We're going to have a value at 2. And then we needed that the limit both exists and that it's equal on both sides. Well, limit's always going to exist for these. We just need to make sure it's equal. So we're going to set, on both sides of this, we're going to set the limit as x approaches 2 from the negative side. When x is less than 2, it's approaching it, from the negative side. We're going to have this function. So this is going to be of k x squared plus 1, right? We're going to want this to be equal to the limit as x approaches 2 from the positive side. So x is coming in from the positive side. For x greater than 2, our function is defined as x plus k. Right? This limit, for any k, we can plug in because this is a polynomial. So this is going to be k times 2 squared plus 1. Right, and it's going to be equal to, plug in again because it's a polynomial, 2 plus k. So you have 4k plus 1 equal to 2 plus k. Right, we're going to want to solve this. We're going to have 3k equal to, we're going to subtract a k over here. We're going to add 1 to both, we're going to subtract 1 from both sides, equal to 1. And so divide by 3, k equals 1/3. Okay. And here we go, problem 5, rates of change. Okay, let's read this. Suppose the position in meters of a skier from the base lodge can model by the equation s of t equals 3t squared minus 4t plus 5, where t is the time measured in seconds. Okay, find the average velocity, average rate of change between t equals 1 and t equals 2. So we're going to use this equation, right? And here, we're doing it between t equals 10 and t equals 1. So it's going to be from a equals 1 to b t equals 10. So we can plug this in. S average equals S of 10 minus S of 1 over 10 minus 1. Right? S of 10 is going to be 3 times 10 squared minus 4 times 10 plus 5 minus 3 times 1 squared plus 4 times 1 minus 5. I distributed the minus sign across this, right? Of course, the 5s are going to cancel. And we're going to have this over 9. So this is going to be 300 minus 40 minus 3 plus 4 over 9, right? It would be plus 1 if we combine these. So it's 260 plus 1. So it's 261 over 9, right? You guys could plug this in your calculator. Is this going to be an even thing from 300? 240? I don't think it is. Let's go see what this is. Oh, this guy's dead. You're low in batteries. Here we go. So this is going to be 261. I haven't used one of these in forever. 261 divided by 9. Oh, it does work out nicely. This is going to be 29. That is our average rate of change. Okay, now we find the instantaneous velocity t equals 1. Here's this formula. Of course, I like to write s prime of a equals, I like to write out the limit as h approaches 0 of s of a plus h minus s of a over a plus h minus a. Of course, these cancel to give you h. Here, a equals 1. That's our value. So we're going to have s prime of 1 equals limit as h goes to 0 of s of 1 plus h minus s of 1 over 1 plus h minus 1. Right, we're going to be able to plug this in. So this is going to be limit as h goes to 0. We're going to plug in 1 plus h to our function. So this is going to be 3 times 1 plus h squared minus 4 times 1 plus h plus 5. Then we're going to have to subtract s of 1, which is going to be 3 times 1 squared minus 4 times 1 plus 5, right? This is all going to be over h, right? So if we FOIL this out, this is going to be 3 times 1 squared plus 2h plus h squared, right, minus 4h, right, distributed that through, plus 5, then minus 3 plus 4 minus 5 all over h. Looks like I forgot to keep the limit. Let's make the limit as h goes to 0. Right, okay, we're going to simplify this one more time. Right, it's going to be the limit as h goes to 0. So we're going to go ahead and send this through. So it's going to be 3 plus 6h plus 3h squared minus 4 minus 4h plus 5 minus 3 plus 4 minus 5 all over h. Right, okay, phew, let's cancel. So we got a plus 5 and a minus 5, that cancels. A plus 4 and a minus 4, that cancels. A minus 3 and a plus 3, that cancels. And it looks like we have a minus 4h and a plus 6h. So it's going to be the limit, h goes to 0. We're going to have a 3h squared, no other h squareds. And then it's going to be plus 2h over h, which is the limit as h goes to 0 of, we're going to put the h through. It's going to be 3h plus 2. Of course, now we can plug in. This is a polynomial. We plug in for h. This is going to be 2. Right? That is the average rate of change. Or this is the instantaneous rate of change. It's going to be 2. That's our answer. All right. I hope that helped. And good luck on the quiz. Maybe I'll see you guys tonight at help sessions.